Hello everyone. Today we will be starting on the third section of the historical uses of metals. We'll be focusing on alloys today. An alloy is a mixture of metals with one or more other elements, usually metals, combined together. So there are examples of solid solutions, but now we'll be focusing on solid solutions, which are alloys. The history of alloys. Alloys were first discovered by accident. It was a contamination of minerals by other mineral impurities that caused the discovery of alloys. Thus, arsenic bronze was discovered because copper minerals contain small quantities of arsenic minerals. Because of the presence of arsenic minerals, when you smelted the copper, you got arsenic bronze instead of pure copper. When these impure copper minerals were smelted, an arsenic bronze was produced rather than pure copper. In the modern era, new alloys are designed to produce materials with the desired properties. Mostly, metals do not have the desired properties. Sometimes they may lack in one of the properties. And to enhance all those properties, what you would do is to add another metal, and that way you would always get the desired properties. And alloys do that. So we will be comparing alloys and metals in terms of physical properties. Alloys are much harder and more malleable than metals, and this is because it disturbs the regular arrangement of the crystal lattice, leading to the formation of a new lattice. Because it disrupts the regular arrangement of the crystal lattice, it provides a much harder and more malleable structure. Alloys are also poorer conductors of electricity, that is because of the presence of impurities, and these impurities are the other metals that are composing alloy. It disrupts the crystal lattice, creating defects. So when charge carriers move in an alloy, it would have many disruptions and therefore it is a poorer electrical conductor. The component metals determine the color of the alloy. So different components would determine the color. For example, a higher copper content will result in a golden color. We will be focusing more on examples of alloys. An example is the 20-cent coin. It's made out of nickel and copper. And there is 75% of copper and 25% of nickel. This is a relatively large percentage of nickel, and that is why it is silvery gray in appearance. However, the $1 coin, which is golden, is made up of copper, aluminium, and nickel. And as you can see, copper content is much more higher than that of the 20-cent coin. And that is the result of the golden appearance. Now we'll be looking at brass, which is an alloy. It is an alloy of copper and zinc. It is much harder than copper due to the presence of zinc, and the color is dependent on zinc content. So as the zinc content goes up, it'll be more silvery in color. Low zinc content results in a golden color, hence used for imitation jewelry. So as I said, if there is a lower zinc content, it'll be more golden. And the typical composition of brass is 67% copper and 33% zinc. Uses and properties of brass. So brass is used for hardware items such as screws and bolts. It is used for these purposes because it's hard, it's readily machined, and it's also corrosion resistant. It is also used for musical instruments, decorative items, and doorknobs due to its luster. Now, solder is also another alloy. It is the alloy of lead and tin. It is composed of lead and tin, and the percentage would vary according to application. That means if some application requires more of the lead properties, it would have a higher lead content than tin content. The proportion of the metals determine the melting point. As you can see, they do not have a fixed melting point, but as you increase or decrease each of the metals that are inside the alloy, the melting point would vary in correspondence. Uses of solder. Solder is used to join metals together, adheres strongly to other metals, and it is molten and solid state. So because of its adhering properties, it is used to join metals together. There are two types of solder. One is electrician solder, which is highly conducting and it solidifies quickly. That means less heat damage. And the second one is silver solder, which does not contain any lead or tin, but it has silver, copper and zinc. So it's got 70% silver, 20% copper and 10% zinc. Steel is also another alloy, and it's an alloy of iron. Steel is categorized into two, carbon steel and alloy steel. We'll look at carbon steel in detail. Carbon steel has three main types of steel. There is mild steel, which has a low carbon content of less than 0.2%. It has these properties mainly due to its low carbon content. It is soft and it's also malleable and ductile. Its uses are car bodies, roofing, nails and chains. Then comes structural steel. It has a moderate carbon content of 0.3 to 0.6%. And the properties include hardness and ductility. The uses are girders, rail tracks, and axles. Now, it is always important to always relate your properties and uses so they're corresponding to one another when you're listing them. High carbon steel is the third type. It has a high carbon content of 0.6 to 1.3%. It is hard and it has a relatively low malleability, which makes it useful for small tools, axes, and cutlery. Now we'll be looking at alloy steels. Alloy steels, there are two types. One is stainless steel. Stainless steel has a metal composition of carbon, chromium, and nickel. Carbon content is relatively low with less than 0.2%. Chromium is around 4 to 30%, and nickel again around 0 to 20%. So these may vary according to application. Properties: they're corrosion resistance and it has a high tensile strength, which makes it very useful for kitchen sinks, cutlery, and surgical appliances. Tool steel is also an alloy steel. It has a relatively large carbon content with 0.9 to 1.5%. It contains tungsten and molybdenum. Tungsten, there's 14 to 20%, and molybdenum, there's 0 to 9%. Properties include very hard, high tensile strength, and heat resistance. So these properties makes it very useful for cutting tools and grinding tools. In this section, we learned about three different types of alloys. We looked at brass, bronze, and steel, and we looked at how they are used in application.